Hello. Now, continuing our work in algebra, we're going to be looking at inequalities where we have quadratics involved and where we have fractions involved, or rational inequalities for the formal name, where we have fractions involved. So we're going to start off by looking at our quadratic situation here. So we have x squared plus 4x plus 3 is less than or equal to 0, and x is an element of OR. If they don't tell you in the question, you're entitled to assume that x is an element of OR, that x is a real number. Now, what we are going to do, the steps for if we have a quadratic inequality are to solve the quadratic like it was just a normal equation, and then we're going to draw a sketch to help us figure out the bounds of our inequality. But first of all, we're just solving a quadratic. We know how to do that. So let's solve the quadratic. We know there's two different ways that we can solve our quadratic. We could use the minus b formula, which I'm going to end up using over here, or we can factorize, and I'm going to remind you of the steps in factorizing. So we take the number in front of the x squared, the coefficient of the x squared, and the constant on the end, and multiply the two together. And then we look for what numbers would multiply together to give plus 3, and then which one of them is going to add together to give the coefficient in front of the x. So 1 by 3, or minus 1 by minus 3. It's a very short list this time. Which one works out? Plus 1 plus 3 gives plus 4. So that's the combination that we want. So we have x squared plus x plus 3x plus 3 is equal to 0. Factorize the first two and then factorize the second two. So we have x on x plus 1 plus 3 on x plus 1. This is just taking out common factors, and then we see we have x plus 1 is our new common factor. That bracket is a common factor, and x plus 3. So we've now factorized this like a normal quadratic. We're going to look for the roots of our quadratic. We'd have x plus 1 is equal to 0, and x plus 3 could be equal to 0. Remember, any number multiplied by 0 is 0. So if x plus 1 ended up summing to 0, that would make everything work out. It would make everything equal to 0. Or if x plus 3 summed to 0, we would end up with everything equal to 0. So either of these things happening independent of each other will give us the result we're looking for. So both are valid solutions. Now I want to rearrange my equation to get x equals. I'm solving this equation. So I take 1 from both sides and end up with minus 1, and x is equal to minus 3. So I now have the roots of my equation. Here's where we come back to the fact we're dealing with an inequality. I'm going to use this and the fact that I know that this is a positive quadratic, therefore it's going to look like a smiley face. We're positive, we're smiling, we have a smiley face quadratic, and I'm going to use the roots to give me a rough sketch of the situation I've got. So I've got minus 1, minus 2, minus 3, and I know that it's going to cross the y-axis at plus 3 because the constant on the end is plus 3. So I know that these are the points on my graph that I'm going to cut, and I know that I'm going to roughly have a smiley face type shape. Within my ability to draw, that is the if situation that I've got. And I am looking for where is this quadratic less than 0? Where is the y output of this function, of this quadratic, less than 0? Well, if I, for instance, put in minus 2, if I subbed in x is minus 2 into my quadratic, I would get out a negative value for y. Y would be less than 0. At that point, it would be negative. So I'm looking for this region down here. I'm looking for that region down there where the y output of my function is going to be less than or equal to 0. So that's how I use my sketch. I'm going to draw a rough sketch using the roots and the fact that I know it's a positive or a negative quadratic, and that's going to tell me what type of situation I am dealing with. And I'm going to have, then from that, I'm going to have x What range of x values am I looking for? I'm going to be looking for when x is less than -1, because I want this blue region in here. So I want when x is less than or equal to, because I have an or equal to here, -1, or when x is greater than or equal to -3. Now I can write that all in one line, but because I can have x is greater than or equal to -3 and less than or equal to -1, it's important to be able to write your question out in that form. So that is how we deal with situations where we've got a quadratic. And the situation for where we've got a rational inequality is actually very similar. There's one extra step at the beginning of it, and the rest of it works out exactly the same way as a quadratic. That's why we handle the two of them together. So again, if you're solving a quadratic, if you're dealing with a quadratic inequality, I should say, you're going to treat it like you're solving a normal quadratic equation, either factorizing it or using the -b formula, which we're going to practice in a moment. And then you're going to use a sketch to figure out whether you are looking for the region in between your two roots or outside of your two roots. If we were asked in the question, when is y greater than 0, when is our quadratic greater than 0, then we would be dealing with this situation out here. All of these x values. So that would be when x would be less than -3, and x would be greater than -1. So that is what would happen if we were looking for where the quadratic was greater than 0, where our y output of our function would be greater than 0. So that's quadratics.